All right. Hey guys, welcome back. Lesson 120. This is it. This is your last lesson. You made it. I hope you are as excited as me because I'm so proud of you guys. And to make it this far, especially given the circumstances, is truly an accomplishment. And I know I say that to you guys a lot on these videos, but it's just because I'm so proud of you. And I know how hard it is when you have to make a big shift in the way that you do things. So I have just been super encouraged by y'all and your consistency and the fact that you've still turned your things in and still been doing well on most of your stuff. That's just awesome. So hang in there because after this, all you've got is a review and a test and you're done. Okay. And then it's summer. So how awesome is that? All right. So the last lesson today is about graphing nonlinear equations. So if you remember a few lessons ago, we did graphing linear equations. So today, and that was one that you watched a video on that I sent you. It wasn't actually me. But today we're going to look at graphing nonlinear equations. So how we do that. When you did linear equations, you were given an equation format. So you were shown how to use y equals mx plus b to help you graph by using the intercept, the y-intercept, and the slope. Okay, so today what we're going to look at, though, is that these are equations that maybe we don't have a set formula for yet. And so when we don't have a set formula for it, like with specific identifiers in that formula, then how do we graph that equation without those things? So let's go ahead and take a look at what that is talking about. Oops, I just hit the wrong button. Sorry about that. Okay, so we are going to look at this one first. So graph y equals 6 over x, okay? So I hope some of you are already right off the bat looking at this and going, Ms. Gutierrez, there's an x in the denominator. And what did we say about that? We know that it cannot be what? 0. That's correct. I know that's what all of you are thinking because I can read your minds. Okay, so we definitely do not want to use 0 whenever we're setting up our x values here. So I went ahead and set up the table, but I did not plug any values in because I want you to see that this all comes from you, okay? So we have to think about what makes sense. The x values, I'm not going to tell you you use these x values every single time and you do the exact same thing because sometimes some x values make sense and some don't given the equation. So let's look at this equation. All that's happening to x is that we're dividing 6 by x. So what would make the most sense here is actually using factors of 6 because we're dividing 6 by x. So we know that 1 is a factor of 6. We know that 2 is a factor of 6, 3 is a factor of 6, and 6 is a factor of 6, okay? So on this side, we're gonna use some positive x's, and over here, it's also important to always check out our negative x's too, and just kind of see, okay, well, what does our graph look like if we use both of these things, okay? So now, once we determined some reasonable, so step 1 is always going to be to determine reasonable x values, okay? So once we have done that, determine reasonable x values. So once we have done that, now we just have to plug them in one at a time to figure out what the corresponding y values are, okay? So if I plug in 1, that just means I'm doing 6 divided by 1. Which would give me 6. So that coordinate then would be 1, 6. Then I'm doing 6 divided by 2, which would give me 3. So that coordinate would be 2, 3. I think you see where this is going. 6 divided by 3 is 2, so that would be 3, 2. 6 divided by 6 is 1, so that would be 6, 1. Okay, same thing over here, except now they're negative values. Well, dividing by something doesn't change the value if it stays the same, but all that's going to change is the sign, because dividing by -1 would give me -6. Okay, so now we're looking at -1, -6. Dividing by -2 would give me -3. Okay, and so on. So the pattern remains the same, but these are just going to be negatives. Okay, so I'm just filling in the rest based on what I know. Now, all we have to do is plot our points on a graph. So let me give us a little coordinate plane over here that we can use, okay? That should give us enough space. Let's use a different color. I'm getting kind of tired of this blue. I've been using it a lot today. How about some orange sounds good. Okay, so we're going to start with these points over here. Okay, so we're going to go 1, which is our x value. So remember that means right 1, up 6, 1, 2, 3, 4, 5, 6. So here's our first point. Then we've got 2 up 3. So that point's going to be about right there. 3 up 2. That point's going to be about right there. And then 6 up 1. So that point is going to be about right there. Then we can plot these points over here, starting with -1, -6. So that one's going to go over and down. 1, 2, 3, 4, 5, 6. Okay. -2, -3. So that one's going to be about right there. -3, -2. And -6, -1. All right. So now, if we look at these, we can tell it's kind of got a funny shape to it, but these all went together, so I'm going to connect those dots. These all went together, so I'm going to connect those dots, and what you may notice is that it forms kind of like these two little swoops, okay? Now, this looks good because, remember, we said our x value can never be 0. Well, if you look, remember, x is 0 right here on this axis, okay? That all those values have an x of 0. Well, here, this line, you see how it's getting steeper, and this line is getting steeper? That's because it's going to keep getting steeper, and it's going to get infinitely close to that axis, but it's never actually going to touch it. That'll blow your mind a little bit. So don't think about that too hard. But you see what I'm saying. All right, so let's look at the next one. We're going to try a different one. But again, all we did was we found reasonable x values. I didn't finish this, sorry, 2. Then you plug those in to find the corresponding y values. Okay, I'm just going to say corresponding y values. Then all you got to do is plot your points to graph. Okay? All right, so let's look at another one. Last one, actually. Now we've got y equals x squared, okay? So same thing we want to think about. First of all, we don't have an x in the denominator, so no, we don't have to worry about like, but we do want to think about here what would be reasonable for x. We always want to think about that, okay? So reasonable values for x here, it really doesn't matter too much, but we could start with just like 0. 0 is always a good place to start. So like 0, 1, 2, 3, okay? The negatives, let's just go, if we go too high, we're not going to be able to fit on here, so let's just go -1, -2, -3. We won't even use this whole, we don't need this one, okay? But remember, we're just squaring them. So here, we're just finding 0 squared, which would be 0. So we've got a point at 0, 0. Then we're going to do 1 squared, which is 1. So we've got a point at 1, 1. 2 squared, which is 4. So 2, 4 would be that coordinate. 3 squared, which is 9. So that coordinate would be 3, 9. Okay, so then -1, remember when we're plugging these in, we're plugging it in like this, -1 squared. So if you're typing that in your calculator, you need to make sure that you put it in parentheses, because if you don't put it in parentheses, the calculator does not read it like this. The calculator reads it as -1 squared if you don't put it in parentheses, and this is wrong. Okay, so make sure you put the -1 in parentheses and then square it. So that would give us a +1, because -1 times -1 is +1. So then we've got -1, 1. -2 squared would be 4, +4. So -2, +4. And then -3 squared would be +9. So we've got -3, +9. So let's plot all of those points. So we've got a 0, 0, a 1, 1, a 2, 4, and a 3, 9. Okay. Then on the other side, we've got a -1, 1, -2, 4, and then a -3, 9. Something like that. So what this one ends up looking like is like a U. And we actually have a name for this type of function. It is called a quadratic function. You'll learn more about that later. But that's just a little preview for you. All right. So again, anytime you've got an equation that you're trying to graph and it's not linear, so you can't use that whole y equals mx plus b thing, you just set up your table, find good x values, reasonable x values, plug those in to find your corresponding y values, then plot your points. That's it. All right, happy homework, guys.